four. From the smallest, the largest would be temporal average, pulse average, Imax, and temporal peak. Okay.
What is IMAX?
It's not on here. It's not on here. It's not listed on here. But that's going to be the average of the highest half cycle right here. This whole average of this whole cycle right here across this time, across that time. Right?
Did you say IMAX is less than IPA?
It's greater. It's greater. It's greater. It's going to be greater. Remember, the PA is going to be across the whole entire pulse. Meaning that when you see a pulse isn't going to just be the same. I'm going to draw over this a little bit. It's not going to be the same intensity all the way across. The pulse is going to be high at the beginning. So I'm just taking the average across that entire pulse, that intensity. But the Imax is going to take the highest one and average this right here, the entire intensity across that pulse, that one half cycle. Okay. So, guys, we're good on the time average. Remember, there's four. How many spatial intensities are there? Two. Okay. Easy to remember. Our spatial peak. Remember, this will be our cross-sectional of the beam. See the distance across the beam? Different than time, right? So, this is our beam right here, guys. This whole thing. This is a great example. This whole thing. This is our beam right here. This is our source. This is the beam shooting out across time, right? So as it travels this way, it's going to lose intensity. If I take this beam right here, and I just need one section, this is my cross-sectional of this beam. So I'll have to cut this out right here, and I need to measure right in this space. This is what the cross-section of that beam would look like. Remember, the examples they're using in the book would be a single element transducer, right? They're using a single element transducers, but all elements are PZT, are they going to behave the same way? All right. So this is our cross section of our single. We're going to have our spatial peak intensities. That's going to be right here in the center of this cross sectional area of this beam, right in the center. Putting it on for the camera. All right. Our intensity spatial average would be our average of this beam intensity across the cross section of this beam. All right. We're good. Okay. So those are our what 6 considerations about intensity. Okay. I'm sorry. Any questions concerning spatial and temporal considerations, guys? Okay, so we know the beam is traveling. You had a question for me? No. Okay. So the beam, of course, is traveling over space and time. So that's going to cause our intensity to be different. Come back to me. All right, but we also have to combine these spatial and temporal factors. Okay, we just can't talk about what the beam is at a certain space. We just can't talk about what the beam is at a certain time. So we're going to have to combine our spatial and temporal considerations. All right? So, and remember, this is all for the study of bioeffects. All right? The intensity characteristics of sound must be described accurately with regard to time and space. All right? So, when they combine these are usually the 4 measurements used to describe the intensity of sound. There's more combinations of these, but these are the 4 most common, okay? And so if you know what these initials are, and you know what they stand for, you can kind of figure out what that's saying. So if it's saying I spatial SPTP, that's spatial peak, temporal peak, right there. So that's going to be measured at the location where the intensity is maximum at a certain space, and the instant in time when the most powerful part of the pulse passes. Okay. So that's going to be the very maximum intensity that this beam is producing. Okay, the very maximum intensity in time and space that this beam is producing. Okay, when we're talking about spatial peak pulse average, that's going to be measured at the location where the intensity is maximum, averaged over the transmit time or the pulse duration. All right. So next thing we have is SPTA, or spatial peak temporal average. That's going to be measured at the location where the intensity is maximum, and also accounting for its average over time, and that includes both transmit and receive times, or our PRP. Okay? That one right there, SPTA, that's the most important when we're concerned in bioeffects. That's what I want you guys to remember for the registry. So they're going to ask that 100%. Which one is the most concerning for bioeffects? Spatial peak temporal average. Okay? Because when we talk about bioeffects, or how sound affects the body, we just can't talk about it with regards to just the pulse, because pulse ultrasound has two components, on and off time, right? So they have to talk about it in regards to the both components of both the pulse, the PRP, and the maximum in space. All right. Our last one would be spatial average, temporal average. Of course, when we talk about average, that's going to be our lowest, right? That's going to be our lowest intensity. Okay, that's going to be measured across the entire cross section of the beam and all over time. That's going to be those averages. So we take this whole entire beam across the time and the cross sectional average. That's how we get our spatial average, temporal average. Okay, and of course that number is going to be the lowest. That wouldn't be a true representation of bioeffects, right? That we're kind of underestimating those values of how it's affecting the body. Okay. Those are the four most important ones. But like I said, there's also more combinations that you can put in. I just want you guys to be able to recognize them mostly. Recognize what they stand for. SATP, I didn't mention that one. Spatial average, temporal peak, they're probably not going to use that one. But again, like I said, SPTA, spatial peak temporal average, that's the most important measurement for intensity concerning bioeffects, which is the whole reason intensities are important anyway. Okay? That's why we're doing this elaboration. We already learned about intensity being one of the acoustic parameters, correct? Right? Okay. Y'all still with me? It's been a long class. The same words over and over again, spatial, temporal peak. So I do want to make sure we all good. We have any questions up to this point?
No, I understand when you said with the time.
Yeah, meaning that this the source, that would be the distance or time that this beam is traveling. And if I was to cross section, I can't open her water bottle, our water's gonna come out. But if I was to cut this right here, I need to measure this beam in this space right here. It's gonna look like a circle, right? Because that's the cross section of the shape of this beam. Remember, when we're talking about cross section, always gonna be regarding the shape of that beam. Okay? Always regarding the shape of that beam. Good question. Alright? So, I'm gonna end right here, guys, with our 10 commandments of intensity. This is kind of a review of what you already know, right? Okay? Intensities, and this is what you need to study when we're talking about the registry. Okay? This is what's important. So when you go back and you're studying for the registry, when you get to chapter 5, you just need to be concerned with the 10 commandments, or the last page, 2 pages concerning this chapter, okay? That's what you need. That's the most important stuff you need to get out of this. Okay? Intensities may be reported in various ways with respect to time and space. What are our 2 ways, Pat? Spatial and temporal. Spatial and temporal. Spatial and temporal. Alright? With respect to time and space. Okay? The different measurements of intensities are important in the study of bioeffects. Again, that's why we're elaborating on intensities, because you just can't take, the beam is not uniform. So you just can't take one space in the beam and say, this is the intensity. That's just the intensity in that one particular space and time. Alright? So, again, like I said, spatial peak temporal average is the most relevant intensity with respect to tissue heating. Okay? That's very important. Remember, cavitation, tissue heating is going to cause, depending on how high that is, but that's going to cause movement of the molecules, which also can cause damage. Right? Alright? The units for intensities are always watts over centimeter squared. Got it. That's not to say, they can use milliwatts over centimeter squared. You know what I mean? So, just watts is just a base unit. Okay? So if you see, because I was doing some reading some other sources, and I come across milliwatts and things of that nature. So, you know, just know watts over centimeter squared, watts is just the base unit. Okay? Peak measurements are larger than average measurements, of course. Peak is taking the maximum value, average is taking the values across that either that space or that time. Okay? So that's always going to be the lowest. So spatial peak, temporal peak have the highest value, and spatial average, temporal average have the lowest values. Correct? Right? A number called the, remember we talked about duty factor already. Duty factor is the percentage or fraction of time that the pulse is being transmitted. Okay? When we're talking about space, a number called the beam uniformity coefficient, the spatial peak or spatial average factor, is kind of like a ratio, or you multiply times 100, you're going to get a percentage, right? All right, kind of like a ratio, and that describes the spread of the beam in space. Okay? The spread of the beam in space. The SPSA factor is unitless and with a value of 1 or greater. You can calculate that number similar to the duty factor. Okay? Spatial peak divided by spatial average. All right? That's going to be our beam uniformity coefficient. Again, because across the space of this beam, is not going to have the same intensity. All right? Okay? You guys know what duty factor is, but again, duty factor describes the relationship of beam intensities with respect to time. The duty factor is unitless with a value between 0 and 1. Okay? Remember, our duty factor is our pulse duration divided by our PRP. Our on time divided by our on time and off time. All right, times 100 to get your percentage. All right, so duty factor will be more concerned with temporal considerations, right? The beam uniformity coefficient will be more concerned with spatial considerations. Okay, SPSA. All right, for continuous wave, when the beam is always on and the pulse average and temporal intensities are the same. Thus, the spatial peak and temporal average equals the spatial peak pulse average, right? Because it's always on. It's always on. It's no listening time, right? So, remember we were talking about the difference between these two would be temporal average versus pulse average. It's always pulsing, right? It's always pulsing across the entire time that it's on. Remember, temporal means all time. Pulse means just the pulse. It's always pulsing. You know, temporal is going to account for the time, the complete time, right? So that's why those are going to be equal. Spatial on a continuous wave transducer. On a continuous wave transducer. Okay, just like the spatial average and temporal average is going to equal the spatial average pulse average. It's going to be the same because it's always on. Okay. When pulse and continuous wave sound beams have the same spatial peak, temporal peak intensities, the continuous wave have a higher spatial peak temporal average. That makes sense, right? Because the continuous wave is always on, so that it's going to be higher the temporal average. And mind you, I'm just taking this last TA. The temporal average is going to be higher because it doesn't have an off time, right? And when we're talking about a pulse transducer, they have that, it accounts for that off time, so it's going to be a lot lower than a continuous wave transducer, correct? Because it's not on all the time. Okay? And the continuous wave, the pulse wave is going to account for the pulse repetition period, meaning the listening time and the transmit time. Okay. And just the opposite. When pulse and continuous wave sound beams have the same spatial average, temporal peak intensities, the continuous wave has a higher spatial average temporal average. Just remember, continuous wave is always going to have the higher intensity across that beam because it doesn't have an off time. Okay, and we're talking about with respect to time. Look, the only thing different between these two are this one's considered spatial peak and this one's considered spatial average. But across time, what makes the continuous wave and the pulse different is that the on time and the off time. Because it's always on, the averages concerning time are always, the average and the peaks concerning time is always going to be higher. Okay?
So the average for the continuous wave will be the 0, 0, line, the x-axis or higher?
It depends on the intensity of that